Hello everyone, welcome back to MrMiers Math Channel. Today in Chapter 10 we're going to talk about shapes of distributions in Day 3. So we're going to describe the shapes of data distributions, we're going to use these shapes to choose appropriate measures, and then we're going to compare data distributions using these data displays. So one of the data displays that we're going to talk about most is a histogram in this lesson. So let's get into it. All right, so a histogram is a type of bar graph that shows the frequency of data values in intervals of the same size, which makes it really good to show the distribution in the data set since the interval is the same size. So when we're talking about shapes of distributions, mainly we want to know, is it symmetric or is it skewed? And if it's skewed, what way is it skewed? Is it skewed to the left or is it skewed to the right? All right, so to start with, a symmetric data set is called symmetric because the left side looks very much like the right side. Okay, that means we have the same thing happening to the left and to the right of the mean in this data set. All right, a data set is going to be skewed when we have data values or outliers that are skewing the data set in one way or the other. Okay, so a data set is skewed left when most of the data is on the right, but some outliers on the left is skewing it to the left here. All right, the tail of the data display extends to the left, and that's how we could say it skews to the left. Okay, all we have to do is just take a look at the tail, and that'll tell us which way it's skewed. So on the right side, we have a data display that's skewed to the right, and it's skewed to the right because most of the data values are on the left, but there's some outliers over here that's skewing this data set to the right. All right, so now that we know what is symmetric and what is skewed, let's move on. All right, so we're going to make a data display using the data that we have, and then after that we're going to describe the shape of the distribution itself. So in this next slide here, we have a table displaying the number of tickets sold from 1 to 8, 9 to 16, 17 to 24, and so on, and then how many people sold that amount of tickets for the raffle. So 5 students sold between 1 and 8 tickets, 9 students sold between 9 and 16 tickets, 16 between 17 and 24, and so on. So we're going to display this data using a histogram. Now, the great thing about a histogram is it's actually really easy to create what we call like that x-axis here. Okay, so the number of tickets sold is going to go along the x-axis, and then the frequency is going to be on the y-axis, essentially. Now, for the frequency, we have to get all the way up to 25. Okay, and I've already pre-designed this, so what we're going to do is we're going to go up by 5s. Obviously, you could pick something different. You don't have to go up by 5s. It's up to you. I'm going to go up by 5s just for ease here. And then in terms of the x-axis, to display how many people sold 1 to 8 tickets, what we're going to do is we're going to write that lower bound, the left side of this interval right here, and then move on to the next interval and write it on the next tick mark. So this interval will represent how many people sold 1 to 8 tickets, this one 9 to 16, and then 17 to 24, and so on. So we're just using that left part of the interval, that lower bound, to create this axis. So then we have 33, 41, 49, and then we also need 1 to show from 49 to 56. So I'm going to write down what this next value would be in that very next interval, which is 57. All right. So now the easy part is just estimating. Now this might be a rough sketch. It might be a little inaccurate. All we want to do is just get a picture of the data set using this histogram. So 5 people sold between 1 and 8 tickets. So I'm going to draw my first bar right here. And then 9 people sold 9 to 17. So we're just going to estimate here. and then 16 people sold 17 to 24. 25 sold 25 to 32, and so on. So by the time you're done, you should have a histogram that looks something, hopefully a little bit neater than this, but something like this. Now, based on this histogram, we can see that this data display is relatively symmetric. Okay, not perfectly symmetric, but relatively symmetric. Okay, we can see that the most amount of data values are in the middle, and then it trails off in both directions, pretty relatively the same. Okay, when we're ever using real data values, nothing's ever going to be perfectly symmetrical. That's not what's going to happen with normal data sets, but it's relatively symmetric here. So let's check out this next example here. So a police officer measures the speeds in miles per hour of 30 motorists. The results are shown in the table to the right here. We want to display the data in a histogram using 6 intervals beginning with 31 to 35. Now realistically, you would have to decide how many intervals you want in your data display and what the intervals are. Okay, we're just starting by giving you an interval, and let's just use it, create a table, and then draw a histogram. Okay, so with this first interval, since this first interval is 31 to 35, that's going to dictate what our next interval has to be. Okay, so if this ends at 35, the next one's got to start at 36. And then also the size of the interval has to remain the same. So if we just subtract these two numbers, we would get 4. Okay, so now all we have to do is add 4 to 36, and that's going to give us 40. Then the next one's going to start on 41. Add 4 to 41, and we get 45. Then the next starts at 46. Add 4, we get 50. Then we have 51 to 55, and then 56 to 60. This ensures that all these intervals are the same width, okay? And then they go up by a steady amount every single time. All right, so now what we got to do is we got to count the frequency. So how many of these motorists, of these 30 motorists, were traveling at 31 to 35 miles per hour? So all we're going to do is just go through this table and count, and I'm going to mark them off as we count them. All right, so for 31 to 35, there's 1. As we go through, that's it. There's only 1. If we look at 36 to 40 miles per hour, there's 1, 2, 3. If we look at 41 to 45 miles per hour, 1, 2, 3, 4, 5. And that's it, 5 for that one. 46 to 50 miles per hour, 1, 2, 3, 4, 5, and 6. And if we look at 51 to 55 miles per hour, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then finally, 56 to 60, we got 1, 2, 3, 4. Awesome. All right, so here's our table, and we're going to use the same table to draw a histogram on the next slide. So I'm just going to copy this table here. All right. So we got that first interval, which is 31 to 35. So I'm going to put 31 right here, and then that next interval starts at 36. So that goes right here. And then we've got 41, 46, 51, 56, and that very next interval would then be at 61. Now, since we have to get up to 11, and I'm not going to go up by 1s, so we're going to go up by 2s here. You could choose something different, of course, but that's what I'm going to do. All right, now we're just going to estimate. So one person falls in this category, 31 to 35. 3 people fall in this category. from 36 to 41, 5 people in this category from 41 to 45, 6 people from 46 to 50, 11 people from 51 to 55, and then finally 4 people from 56 to 60. All right, so first, in order to answer these questions below, we want to figure out, is this data distribution, is this symmetric or is this skewed? And of course, in this one, we could see that this is symmetric. If I just draw a little curve, roughly outline some of these boxes here. All right, we can see that the tail is on the left side. There's some values to the left that's skewing this data set. Most of the motorists are speeding, okay, and speeding by, probably a significant amount. And then some of the people are going the speed limit or even under the speed limit. And those are the outliers, those people that are probably going under the speed limit. All right, so which measure of center and variation best represents the data? Well, that's based on the type of distribution we have. Since this is skewed, the measure of center and variation that best represents the data would be the median and 5-number summary from what we've learned so far. All right, so the median would be better than the mean, because since this is skewed, that's going to skew the mean. Okay, and then the 5-number summary would be better than the standard deviation for the same reason. Since this is skewed, a 5-number summary or a box and whisker plot would give us a better representation of what's normal in the data set. All right, then the speed limit is 45 miles per hour. How do we interpret the results? So obviously, if the speed limit is 45 miles per hour, just drawn on the graph here, okay, most of the people here are speeding. All right, so this is just how we could do a really basic analysis by displaying our histogram and data distribution. All right, so in the last 2 slides here, it's going to be pretty simple. Choosing appropriate measures. So when it's symmetric, we could use the mean to describe the center and standard deviation to describe the variation. And then when the data distribution is skewed, we could use the median to describe the center and 5-number summary to describe the variation of the data in the data set. Okay, that would be a little bit better. All right, right here, just a little tip. It says, when a distribution is skewed, the mean will be in the direction in which the distribution is skewed, while the median will be less effective. And that's why we would use the median when the data distribution is skewed. Okay, in this last example, we just have 2 tables talking about emojis. So amount of text messages using emoticon messages. So between female and male students here. All right, so here's the data display for the females. Here's the data display for the males. I believe this was accurate when this was polled. And what we're just going to do is just compare the distributions using their shapes and appropriate measures of center and variation. So if we take a look at the female data set, we can see that that is symmetric. So since it would be symmetric, we would use the mean, or we could use the mean and standard deviation to describe the measure of center and variation. If we take a look at the males, we can see that this is skewed to the right. And that means for our measure of center, we'd probably use the median, and for the measure of variation, we would probably use the 5-number summary, or our box and whisker plot. Okay, maybe what we could say if we want to really compare it and talk about what is the difference between these 2 sets of populations in this instance is maybe when the time it was polled, yeah, females used more emoticons than males did. I'm not sure if that's accurate anymore. All right, but that is it. We talked about data displays, distributions, making a histogram, and talking about symmetric and skewed data distributions. So if you enjoyed this, or if you found this helpful in any way, please like, subscribe, and share. Thank you, and have a great day.